Okay, so in this tutorial here, what we're going to be looking at is the couple problems that relate to Venn diagrams. And so, some of them you don't even really need a Venn diagram. You could do the problem without even using the Venn diagram, but we're just going to include it for now just so that you get used to seeing some possible examples of this. So let's say you go camping with some friends and there's a big cooler and it's full of pop. Let's say there's 10 Cokes, 7 Sprites, 20 root beer, and 5 Orange Crush. Calculate the probability of selecting a Coke or an Orange Crush from this cooler. So we're going to include a Venn diagram just to talk through it and just to see different ways of doing this. So what we're asked to find is basically the number of Coke, or I'll say OC for Orange Crush, like this. Which the other way of writing it is just CU and then Orange Crush, like that. And so, all we need to do in this case, since these are mutually exclusive objects, right, where there's no overlap of these things, so we know it's just finding out the number of Cokes plus the number of Orange Crush. And so the number of Cokes are 10. The number of Orange Crushes are 5. And so there are 15 in there, like that. The other thing that we note is that the total universal set contains, if we look at it, it's 10 plus 7 plus 20 plus 5, which is 37, 42. So there's 42 in total. So the probability of getting a Coke or Orange Crush is just 15 over 42, like so. And you just put that in your calculator and you get the answer, or the final decimal value. I'll do that right now. So 15 divided by 42, and we get about 36%, about 0.36. Okay, so that's one way to do this. How can we visualize this with the Venn diagram? Well, we could say the universal set is the set of all drinks that are in this cooler, which we know is there are 42 in total. We could say that one of these sets is the Coke, and the other set is the Orange Crush. The union of these two things would be however many of these there are, plus those. They're disjoint, and we know that Coke, there were 10, Orange Crush, there were 5, and then the other ones that are not any of those, right, which is not Coke and which are not Orange Crush, which are the 10 and the 5, is 27. 27 of the other pops are not those two. Okay, so that's all you have to do. And so when you're solving this and you're saying, well, what's the probability of getting this or this, you would just take 10 plus 5 and divide it by 10 plus 5 plus 27, which is the total number. So you get 15 over 42. And that's all you have to do. I mean, you could have done this question without it right at the beginning. You could have said, oh, the probability of Coke or Orange Crush is just, there's 15 over the total, and you would have got the same number. But using the additive principle here, we can just show the steps to get that same result, and also to see the Venn diagram solution to visualize what's happening. But again, you probably would have solved this quicker without having to use the Venn diagram, but there's other problems that become very challenging without the Venn diagram. Okay, let's take a look at an example. All right, so Provincial Park has 220 campsites, okay? So this would be, S will be the universal set of all campsites. So we could say all campsites, great. A total of 80 sites have electricity. Of the 52 sites on the lake shore, 22 of them have electricity. And if a site's selected at random, calculate the probability that, and then it will be on the lake shore, it will have electricity, so on and so forth. Okay, so let's call one of these sets electricity. I'll call it E for electricity, and the other one I'll call L for lakeshore. So E is electricity, and L is lakeshore. Okay. It says of the 52 sites on the lakeshore, 22 of them have electricity. So here's the set of lakeshore campsites. 22 of them have electricity. And there were 52 sites on the lakeshore. But if 22 of them have electricity, I can't write 52 here because that's too many. So I have to write 30. So 30 of the sites are on the lakeshore but don't have electricity. 22 of the sites are on the lakeshore as well and have electricity. So we've got 22, that makes a total of 52. If a site is selected at random, calculate the probability and then from there. So a total of 80 sites, I knew I was missing something, 80 sites have electricity. So in this case here, 80 less 22, there's 58 campsites in total that have electricity but are not on the lakeshore. So 58 and 22 gives us the total of 80 sites with electricity. And now if we add these up, if we say, well, 58 plus 22 plus 30, that's 110 sites. So this represents 110 campsites. But there were 220 campsites in total. So that means if we do 220 less 110, we actually end up with 110 that are not in the lakeshore and also do not have electricity. Okay, you probably could have figured that out on your own as well, without maybe even without a Venn diagram we could have done this. So what is the probability that it will be on the lakeshore? Well, probability that's on the lakeshore, there's 30 that are on the lakeshore with no electricity, and there's 22 that are on the lakeshore and have electricity. So if I were to shade this circle here, just lakeshore, I get a total of, there's 52, and the total number of campsites is 220. So the total number in the universal set of campsites is 220. Okay, so in this case we just go 52 divided by 220 is 0.24. You have about a 24% chance of grabbing a site on the lakeshore. Okay, what's the probability that it will have electricity? Well, the probability it will have electricity, 58 plus 22 is 80 over 220, like that. 0.36. A little more likely that if you grab it randomly, that it will have electricity. Now let's say it says it will have either electricity or be on the lakeshore. So the probability that it will have electricity or be on the lakeshore is, there's a couple ways to do this. You could simply add up 58, 22, and 30 to get, if we do it that way, we would get 58 plus 22 is 80 plus 30, it's 110 over 220, 0.5, or 50% chance that it will be either or of these two things. So or is the union of these sets, so we have to include all of it. Okay, the other way you could have done it is if we use that equation we had before, like this, but I doubt you will do it this way. You would say, what's the how many were on, how many had electricity? It was 80. And how many are on the lakeshore? That was 52. Subtract the intersection over 220, and you'll see here that when you do that, you end up with exactly the same thing, which is 110 over 220, which is the same result. So that's using the principle of inclusion and exclusion that you saw before, that we had before, which says, you know, if you take 80 plus 50 and subtract 22, it's subtracting the intersection of those two things. Okay. What's the probability that it will be on the lake shore and not have electricity? So the probability that it's lake shore and no electricity. Well, look up here. Probability of lake shore but no electricity. You would shade this part up here. And when you shade that part there, you see that's only 30 sites out of the 220 are in that situation. And so we just go 30 divided by 220 is about 0.14. It's about 14%. It's 13.6. Okay, another option here says it will be on the lake shore. No, sorry, it will not be on the lake shore nor have electricity. So the probability that no, not lake shore and not, or nor, yeah, not electricity, that's fine. Well, those are all gone, those 110. So the probability that it will be on the lake shore and nor have electricity, so neither of them, is it's everything that's shaded outside of the Venn diagram. So we want to exclude all of this stuff and only include the stuff that's left over, which we know is 110 from our previous calculation. So it's 110 over 220. You have a 50% chance of that happening. Just like you had a 50% chance of it being electricity or on the lake shore. The other option is that if it's not on the lake shore nor have electricity, it would be the other 50%. So again, the Venn diagram, even for this is a simpler type problem, the Venn diagram here makes it very easy to calculate probabilities when things are overlapping. Okay. Look at this one. Okay, here we have a set of 3 sets. It says use the Venn diagram below to answer the following questions. And again, you could probably do these on your own at this point, and you could try them and then just come back to this video quickly and check your answers. Okay, so we've got people that like rock, people that like rap, and people that like country. And there's a universal set here of people that like music in this case, but there's no numbers outside here in the universal set. So therefore, we can assume that no one in this case is there that doesn't like any of these things. So we're making that assumption because there's no data on that. It says how many total people are represented in this diagram. So the number of people, let's call them P. Okay. So total number of people here. Well, I'm going to add them up, and I'll find out how many people like only rock, only rap, only country. How many people like how many people like rock and country, but not rap? How many people like rap, rock, and country? How many people like rap and country, but not rock? And here you have the people that like rap, rock, but not country. Okay? So all you need to do to find this is you simply just add this all up. You go 18 plus 11 plus 24 plus 8 plus 7 plus 1 plus 17. And if we add these up properly, we should get 18 plus 11 you get 86. You can check my math there. I did it pretty fast here. So 18, 11, 24, 8, 7, 1, 17, 86. Okay. It says how many people like country? Number of people that like country. Well, all of these people like country. So that would be 8 plus 7 plus 1 plus 17. So 8 plus 7 plus 1 plus 17, about 33 people like country. Now we get into some probabilities. It says here, if one person is chosen at random, what is the probability that the person will like rap music? Okay, so probability of rap. So probability of rap is, so if we randomly grab someone, all of these people like rap. So we have 11 plus 24 plus 7 plus 1 divided by all the people in this survey or in this questionnaire that was happening here, and that's 86. So we just go 11 plus 24 plus 7 plus 1 is 43 out of 86, which you can clearly see is 0.5 or 50% of the people like rap. Okay. If one person is chosen at random for this next part, what is the probability that the person will like country or rock music? Okay, probability of country or rock. Okay, so we look, country, rock, and we add up all, oh, you can't see that. You can see here, here's the people that like country, or sorry, rock, and the people that like country. And so the union of these two sets is this big thing here. Okay? And so this is the union of it. We can just add up each of those numbers to find the total. That's all you have to do. Okay. So now you could add up, there's the other way you could do it as well, where you could add up all the people that like rock, then add up all the people that like country, and then subtract the intersection, because you would have double counted these two numbers. So if you added up all those, you would have to subtract the 8 and the 7 because you double counted them in each one. So subtracting them off once gets you the proper value. Or you can just go that plus that plus that plus that plus that plus that, and that's it. So I prefer that method where you just add them up instead of having to do all the subtractions. So it would be 18 plus 11 plus 7 plus 8 plus 1 plus 17 all over the total, which was 86. And so we just, at this point, we're just punching in simple numbers on the calculator. So we go 18 plus 11 plus 7 plus 8 plus 1 plus 17, 62. It's a lot of people. It's the majority. Divided by 86. And we get about 0.72, or about 72% of the people like country or rock. Okay, last one here. If one person is chosen at random, what is the probability that the person will like country and rock? So I did it that way this time, or I could use the intersection symbol. It's up to you. So the probability of country and rock. So we come up here, and we can see that country and rock is this section right there. 8 and 7. Okay. So when we come down here, we just go 8 plus 7 divided by the total of 86. It's 15 over 86. And so 15 divided by, it's about 17%. So the probability is 0.17 or 17%. Okay. There actually is another way to get this, and we could have, the 8 plus 7. We know that the OR of rock and country is this added together, okay? And then you would subtract off the center. Well, if you took the total and then, you could have subtracted off these numbers here, and you'd be left with that. So I mean, you could add them all up, subtract off the other two, and you'd be left with the intersection as well. So it's using that formula we had before, and you could just rearrange that formula for the intersection part, and you would find out that it would just be 8 plus 7. Right, so that's one way to do that as well. I mean, that's a more complicated way. You probably wouldn't want to do it that way. So you would probably just look here and say, like, let's just find this intersection part and add up the total that are in there. Okay, there's a series of questions that involve, you know, when there's overlap and no overlap. You're going to be writing out some diagrams, creating some Venn diagrams as well. And we'll also move into some more challenging ones later that I can give you as well for examples and for challenges. Okay, so that's what we're going to work on next. Thanks.